Hello. For our first e-learning day, our objective is going to be, I will be able to determine if a relationship has a positive, negative, or no correlation. I will also be able to find clusters and outliers in a scatter plot. So if we can do all that, you'll be at an A for today. Alright, my expectations to be kind of present for today, not absent, is that you need to submit your notes from this lesson to Canvas, and you need to complete the exit ticket link on Canvas. All of this is going to be worth 15 homework points, not just 5. So it's worth it to get it in. Alright, our first vocabulary term is correlation. Again, you can take notes on the computer, or you can take notes on a piece of paper. It doesn't have to be a nice piece of paper. It just needs to be something that I can see and you can turn into the computer for me. So, correlation is a mutual relationship or connection between two or more things. So all of those scatter plots we did yesterday, those were correlations. So, in a positive correlation, as X increases, Y also increases. Right? We can think of these correlations if we even sometimes if we use Mr. Multiple Division and we kind of just think to ourselves, positive, if X is increasing in positive, a positive and a positive make a positive. Alright? So that means increases make a positive. On the other side of that, a negative correlation is as X increases, Y decreases. So now we have a positive and a negative, which makes a negative. And then lastly, we have no relationship. So if a correlation has points everywhere, all over the place, it's no relationship. So just a couple examples of this. No relationship looks like points literally everywhere. You cannot tell if they're going positive or negative. A positive relationship has points going up. And a negative relationship has points going down in sort of a pattern. At any point, pause the video if I'm going too quickly for you to write it all down. Alright, next we have clusters and outliers. So, clusters are two or more data points gathered around a particular value. So that would be this second graph here. This is a cluster, this is a cluster. Okay, they're points fairly close together gathered around the same value. Then we have an outlier. It is a point on the graph that is far from the other points and does not seem to fit the pattern. So an outlier is normally fairly obvious. There's a pattern in the graph, and then the outlier is the one all the way out of the path of the graph. So on the second one, there's the outlier. Alright, so just do a few examples. So if I'm looking at this graph, alright, I notice that as X increases, so as X increases, that's this way. As people watch more TV, alright, I look at Y and I'm saying, okay, this kind of looks like it's going downhill. So as X increases, Y is decreasing. So if I have a positive and a negative, an increase and a decrease, that means that the graph is showing a negative correlation. Alright. If I was asked to look for clusters, I would say that there is a cluster here. Okay, or here. And an outlier point that doesn't fit the trend would be this point way down here. So this person's not watching a lot of TV, but still kind of failing class. Alright, next. I notice that as X increases, Y is doing nothing. Like, you cannot tell. The points are everywhere. Okay, and that makes sense. I mean, age and how happy you are does not have a correlation. Alright, so So this graph is showing no correlation. There are no clusters. There's no point that has a bunch. Like if there was something like this, that'd be a cluster, but there's not. And there's no outlier because there's no trend to follow. There's no outlier or random point. Okay, lastly, as x increases, so again, as x is going this way, all right, y, I see a trend this way, so y is increasing. So if they're both increasing, that's positive. Right. I would say the data points are clustered around here, like at the bottom. And then, are there any outliers? Well, this one might seem like there is. It might seem like this point right here is an outlier because it's far from the other points. However, if I put a line through these points and fit the trend, this point is very close to what the trend is, and so it is not an outlier. All right? If it was over here, it'd be an outlier. Or if it was down here, it'd be an outlier. Because it kind of follows the trend that we see, it is not an outlier. Alright, so now we're going to take some word problems and identify the correlation you'd expect to see between each pair of data sets. So we're going to start with the outside temperature and the number of people wearing gloves. So what I like to do is I like to draw arrows. You might remember this from last year. And then I always like to start with the first part of my sentence. So that would be the outside temperature. Right? I always like to think about if that is increasing. So I always am going to draw an arrow going up on the first part because it just makes sense to me. Right? And the first part is always like the x, and we're always saying as x increases, what's happening to y. And that will help make you less confused. So as the outside temperature is going up, increases, and then what happens to the number of people wearing gloves? Well, the number of people wearing gloves should go down. Right? Because as it gets warmer, you don't need to wear gloves. So, as the outside temperature increases, the number of people wearing gloves goes down. That's a positive and a negative, so it's a negative correlation. All right. Okay. Length of hair and drying time. So again, I'm always going to just start with the first part going up. Okay? As long as that you do it that way, it'll be less confusing. So, as the length of hair increases, what happens to the drying time? Well, the drying time increases generally. Okay, the longer the hair you have, the longer it takes for it to dry. And so if they're both positive, as x increases, y increases, we have a positive correlation. And then lastly, shoe size and average in math class. So as shoe size increases, what happens to your average score in math class? Nothing. Okay, those are not related at all. I'm not grading you based on the size shoe you wear. All right, so there's no correlation. Oops, sorry. Correlation. All right, so again, what you need to do is you need to go back to Canvas. You need to submit a picture of your notes paper, all right? And then you need to follow the link to the exit ticket. And whatever you, like, this is again worth 15 points. If you have any questions, email me. I will be on my computer all day.